Hey guys, we are on day 2 of Unit 11, and we're going to talk about rotations and angle terminology. So when we talk about trig with Algebra 2, it is mainly dealing and originating from what we call the unit circle. Okay? This unit circle idea is a lot of little ideas all coming together. So this unit for a lot of the first couple of days is not going to make a whole lot of sense until we all put all the little ideas into one big picture. All right. So just bear with each day that we learn a little new thing because it might not seem like it's related to what we did the day before. So hopefully that makes sense. All right. So at the top, it says in this unit, we will be focusing mostly on our 3 basic trig functions, sine, cosine, and tangent. And these functions are based on the geometry of a circle and rotations around its center. Sometimes the trig functions are known as circular functions because we are going and rotating around. Okay, so when we start talking about our angle theta, all right, our angle can be 0 degrees, okay? And if we rotate all the way around, could be 360 degrees or anywhere in between, all right? So when we start talking about angles of rotation, we do them on a graph, okay? And we talk about angles in what they call standard position. And that is an angle with its vertex at the origin. Okay, so our angle will have its vertex at the origin and its initial ray. There's 2 sides of an angle called rays. The initial ray will be on the positive part of the x-axis. So on our x-axis, we have a positive and a negative part. And on the positive part is our initial ray. That ray doesn't move. He stays exactly where he is the entire time. It's the other side of the angle that moves. And that's called the terminal ray. Okay, so it also is stuck at the origin, all right? And our terminal ray, like hands on a clock, this one moves, all right? But our initial ray does not. And that terminal ray can be anywhere, all right? It doesn't have to be open that much, okay? But if it is, it changes obviously the angle, all right? So here we go. On our graph, if that that red terminal ray is all the way closed, that angle measures 0 degrees. Okay. If that terminal ray is pointing straight up, then it measures the angle, it measures 90 degrees. Okay. If that terminal ray is all the way open, all right, so it is on the negative part of the x-axis, then you are at 180 degrees. Okay. If that terminal ray is all the way open, pointing down, then that angle measures 270 degrees. Okay. If that terminal ray has made it all the way around and it's back to where the initial ray is, then that measures 360 degrees. Okay. Now, that terminal ray can also rotate negatively. All right, so let's go down here to rotations. Positive rotation, terminal ray is rotated counterclockwise, or the same way the quadrants go. All right, and the quadrants go quadrant 1 to quadrant 2 to quadrant 3 to quadrant 4. So if that terminal ray is rotating the same way the quadrants go, then that's positive rotation. Same thing from geometry. Okay. However, that terminal ray can also rotate negatively if you rotate it clockwise. So for instance, if that terminal ray is showing an angle of 0 degrees but then rotates down, then that would be negative 90 degrees. If it continues to rotate, then it would rotate negative 180 degrees. If it continues to rotate and point straight up, that would be negative 270 degrees. And then if it continues to rotate back onto the initial ray, that's negative 360 degrees. Okay. We are also going to have to talk something about reference angles. Okay. Reference angles are a little bit hard to understand, but they are positive and acute angles formed by the terminal ray and the x-axis. Okay. It is the shortest distance an angle is from the x-axis. So we're going to have to study those. Okay. There's also something called coterminal. Okay. Co meaning same, terminal meaning end. Same end. Okay. There are any two angles drawn in standard position that share a terminal ray. They look the same, but are different measures. Okay. They end up in the same exact location, all right, but they have different measures. All right, so we're going to practice both of those coming up. But first off, let's make sure that we understand that if they give us an angle measure, that we can tell in what quadrant that terminal ray will fall in. And I really hope visuals help you. So I got little graphs here so we can draw them out so you can see them, okay, and understand them a little bit better. So in number 1, it says for each of the following angles, draw a rotation diagram and identify the quadrant that the terminal ray falls in. So first thing we're going to do is we're going to put the vertex of all of our angles at the origin, and we're going to put all of our our initial rays on the positive part of the x-axis, because this part of the angle does not move. Okay. What moves is the terminal ray, or the other side of our angle. But our angles always have their vertex at the origin, and this is the initial ray of them. Okay, all angles have 2 rays. So our first ray has been drawn. Now, if our angle is 145 degrees, that means it is open, let's see, straight up would be 90, so it's got to be open more. If I open it all the way up and create an opposite ray here, that would be 180. So I'm going to go ahead and say somewhere in here will be my terminal ray. So that if I were to measure this angle between the initial ray and the terminal ray, that would be 145 degrees. This terminal ray is ending in quadrant 2, okay, or falling in quadrant 2. Okay, and there's our answer. So what would be called a quadrant 2 angle. Okay. All right, part B, 320 degrees. All right, so 90, 180, 270. If I keep going to 360, so it didn't quite make it to 360, it's at 320. Okay, so it's somewhere in here is my terminal ray of my angle. And so when I measure from here all the way to here, that's 320 degrees. Now my terminal ray is down here in quadrant 4. And so that is where my terminal ray falls in order to measure an angle of 320 degrees. All right, part C, 72 degrees. Well, I know straight up is 90, so 72 is less than that. And so this angle here would measure 72 degrees. Okay, and it is lying in quadrant 1. Okay. Part D, 250 degrees. So straight up is 90, horizontally would be 180, straight down is 270. It didn't quite make it to 270. So I'm going to go ahead and draw it over here so that if I were to measure this angle right here, that would be 250 degrees. My terminal ray is down here in quadrant 3. Okay. Next up, part E. This one's a little bit on the tricky side. So 460, you have to realize, is more than 360. Okay. It's 360 degrees plus another 100 degrees. Okay. And so what happened is that my angle went all the way around in 100 degrees more. All right. So 90 degrees more would be straight up. So 100 degrees more is more like here. Okay. Now watch how I draw it. So I went all the way around and then 100 degrees more. So that angle would measure 460 degrees if you trace my green path there. And it ended up in quadrant 2. Okay, so you might say 100-degree angle, excuse me, looks the same as a 460-degree angle if I didn't draw that green path, and therefore they would be coterminal. All right, so part F. So this one, we got to watch out for, that has a negative on it. So negative means that we have to rotate down and around, okay, also known as clockwise. So if I go down, that would be negative 90. If I keep going, that's negative 180. And if I keep going, that's negative 270. And if I keep going, that's negative 360. So negative 310 is probably somewhere around here. Okay, but watch how I draw it. You have to rotate down and around this way to hit up negative 310 degrees. Okay, and we ended up in quadrant 1. So that's where the terminal ray falls. Okay, part G. Negative 210. So again, it's a negative angle. So we're going down and around. Down would be 90. Keep going is negative 270. Keep going is negative 270. Okay. And so we ended up somewhere around here. Okay. So that this would be negative 90, negative 180, negative 210. Okay. And we ended up in quadrant 2. All right, last one, part H, negative 400 degrees. So we have to realize that that's negative 360 plus a negative 40. All right, so if we go all the way around, that's negative 360 degrees, and then we want to go 40 more. So we're going to go end up right around here. Again, watch my path. We're going down and around to rotate negative 360 degrees, and then 40 degrees more would put us at negative 400 degrees. Okay, and we are ending in quadrant 4. And same thing that you guys might say is negative 40 degrees looks the same as negative 400 degrees. And so those angles are known as coterminal. All right, they look like they end in the same spot, but if you look at the rotation of them, the rotation, where I draw in green is not the same for those two angles. Okay, but if you just look at the initial ray and the terminal ray, you might say, oh, hey, that's negative 40 degrees or negative 400 degrees, depending that we kept going around. Okay, all right, I will see you guys on the backside of notes.